record the session. And then let me bring up that on the left, that on the right. Blow that up a little bit. You want to start at the beginning, or have you done some of these already?
No, I haven't done any yet.
All right. Before we do anything, let's talk about the general equation for a sinusoid function. What is it? What have you been taught? Because there's actually a few of them.
Here, let me check.
Usually A, everybody uses A. And everybody uses B. To me, this is the best one right here. Make sure that that's the same one that you've been taught. Because there's a few variations of this one, and some school systems teach those. One has B inside the parentheses, so it's bx minus c inside the parentheses. And some use different letters than C and D. They might use H and K or, whatever. But
yeah, that's what I was taught, but instead of sine, it's cosine.
Well, this is called a sinusoidal function. And what that means is that you can have either sine or cosine there. Not usually tangent, but sine or cosine. Whichever fits the minimal amount of phase shift is the one you want to use. But just because it's called a sinusoidal function doesn't mean it's sine only. When I write it, this can be sine or cosine. The key important thing in this general formula here is whether your B is on the outside of the parentheses or on the inside, because it makes quite a bit of difference on how you graph it.
Okay.
All right. So if we're agreed on that, and if you have something different, let me know. In other words, if you have, here's one that's taught in the state of Colorado, and that's tremendously different.
Mine's the same as the top one, except for the B is inside brackets. So it's like sine bracket B parenthesis x minus c parenthesis bracket. Does that make sense?
Yeah, it does. I don't know why they have the bracket. In other words, you have a bracket like this.
Yes.
Well, that bracket isn't needed. I see why they have it now that I look at it, but it doesn't make it the same as the bottom one. So let's erase this one. Although sometimes, in other words, this is a game. They're going to give you a sinusoidal function and they ask you to graph it. That's part one of the game. And part two is they're going to give you a graph and ask you to come up with the sinusoidal function of that graph. And then if they really want to get hard, they'll give you a word problem involving tides or seasons or any periodic function and ask you to come up with the sinusoid of that model. So this can get kind of tough, but it's very, very important that we establish a standard as to what our general format's going to be. And okay, like number 2 is this format. Even though they include the extra set of parentheses, it's still this format. Okay, so let's do number 1. Give me an equation of a sine function with an amplitude of 3.
So that just be y equals 3 sine B,
Huh?
and then X.
Sine of X. That's the simplest one you can give. In other words, there's all kinds of them. I could also say sine of 2 times x minus 1 plus 3. That also has an amplitude of 3. But usually in a question like this, give the simplest answer you can possibly give.
Would it be okay if I just put the whole equation after that?
The only thing that matters is that a equals 3. Well, yes, no, it would be incorrect to do that. In other words, if I were to do this, that would not be a satisfactory answer. If I were to say this, no. In other words, this is the general equation. There's a big difference between the general equation and a specific equation. A specific equation has values for A, B, C, and D. And when I wrote this, B was 1, C was 0, and D was 0. But this is a specific equation. And it's important to understand the difference between a general equation and a specific equation. Okay, and they said write an equation of a sine function. Well, that would fit a sine function with an amplitude of 3. And like I said, as long as a is 3, everything else can be different numbers. That you don't want to leave them as letters. You don't want to leave the B, the C, and the D in there. You could put in any numbers you want for B, C, and D, but put in numbers. Okay, in other words, whenever you have a specific sinusoidal function, it's always something like this. Let me make the most complicated one I can think of. How about this one? Sine of 3x minus pi over 2 plus 10. Okay? There is a sinusoidal function that could describe most anything. Maybe, who knows what it describes. But it's got a negative sign. It's got 7 as the amplitude. It's got a b of 3. It's got a phase shift of pi over 2. And it has a vertical shift of 10 upwards. So if they were to say, what's the amplitude of that complicated function, what is it?
-7.
Actually, the amplitude is said to be the absolute value of that. So the amplitude is actually 7. The negative sign merely means that it's being reflected over the x-axis. Okay? Now, one thing that really I've never understood in Common Core math is why they treat this function any different than any other polynomial. Everything is the same. That is a reflection over the x-axis. That is a vertical stretch factor. That is a horizontal scrunch factor. That is a horizontal shift, and that is a vertical shift.
Okay.
So this sinusoid function is really no different than what you've just studied with transformations. Everything is really exactly the same, and I don't know why they don't call it that, but they don't. When you get the sinusoidal function, they act like it's from Mars and polynomials are from Venus. But everything actually fits the definition of transformations. Okay, so let's look at one of these other than that first one. Let's look at number 2. Now, okay, let's talk about A is the amplitude, right? In other words, if I have this, let's talk about what each of these letters are. A is the amplitude. Okay, I'm going to list this function I've just drawn is y equals sine x. Notice the amplitude is 1. So if I said to you y equals 2 sine x, what would that look like in blue?
Be going up to.
Yeah, it would look like this. In other words, it would go up to 2. It would have the same frequency. In other words, the period is 2 pi, but it would go, instead of from -1 to 1, it would go from -2 to 2. Okay, so that looks like a vertical stretch factor, right?
Yes.
Okay, now let's look at a different one. Let's look at what would y equals sine of 2x look like. Well, notice that the 2 is the b. And this is very important. You have to remember this. B equals the period divided by 2 pi, which also means the period equals b divided by 2 pi. Both of those statements are true. Well, in this case, we know what b is. It's 2. So what's the period? Hold on, I made a mistake. Sorry, hold on a second. B equals the period divided by 2 pi, which means the period equals, hold on.
In my notes, I have 2 pi over b equals period.
Yeah.
Or 2 pi over period.
No, that's correct. That's correct. I don't know what I was thinking. Period equals 2 pi over b, which means b equals 2 pi over period, right? So when I say sine of 2x, what's the period?
Wouldn't it be pi?
Yeah. Okay, and that's right there, which means I have to draw my entire sinusoid curve within that period. You see what I just did? That's the sine of 2x. I'm taking these one at a time because I think it's important to look at them one at a time. Obviously, all the questions you have here have multiples. In other words, number 2 has a B, has an A, and it has a C. But the way to understand these is to look at them one at a time. Notice that when B is greater than 1, in this case it's 2, it's a horizontal scrunch, correct?
Yes.
Just like with polynomials. When inside the function is greater than 1, it acts as a horizontal scrunch factor. Not a stretch factor, but a scrunch factor. In other words, it reduces the period. The period is normally 2 pi on the sine or cosine function, but because b is now 2, the period becomes pi, which means you have to be able to draw one full cycle of the function in the period. Okay, now let's look at C. What if I said this? Y equals sine of x minus pi over 4. Well, first of all, let's see.
Pi over 4.
Does that mean it looks to me like a horizontal shift if it was a polynomial, right? And it is, but which way? Right or left?
I don't know.
To the right. In other words, the standard is always x minus c. Right there. Okay? In this case, c is a positive pi over 4. And positive pi over 4 means a shift to the right. So I'm going to take my black curve, which is sine of x, and I'm going to shift it. There's pi over 4 right there. So instead of starting it at the origin, I'm going to start it there, and nothing else changes. Does not change the shape of the black curve. It just horizontally shifts it to the right by pi over 4.
How do you know that pi over 4 is there, though?
Because that's what it says in the function right there. That's what c is.
Yes, but how do you know?
C is your phase shift. C is your phase shift. If c was pi over 2, then I would shift it pi over 2 to the right.
No, I understand that part, and I understand that starts at pi over 4, but how do you know where pi over 4 is on the actual graph?
Well, the actual graph, if I go back to the black graph, which is merely y equals sine x, remember that's 2 pi. Okay? And these x coordinates are very important. These sinusoidal functions, you want to be able to quarter up. By that, I mean if the end of the period is at 2 pi, then halfway through the period is pi. 3/4 of the way through the period is 3 pi over 2, and 1/4 of the way through the period is pi over 2. It's very important to be able to quarter up these sinusoidal functions because they're liable to start at anywhere. In other words, they might start at 3 pi over 11 and go to 11 pi over 11. And then you got to quarter it up. Okay? Quartering it up is important because notice the peak of the function occurs at the first quarter. The 0 of the original function occurs at the second quarter, pi. The lowest point of the function, minus 1, occurs at the 3/4 point, and you get back to the starting point at 2 pi. So 2 pi is the period of y equals sine x. Very important to know that. It's always 2 pi. It's also the period of y equal cosine x. It is not the period of tangent x. Pi is the period of tangent x. But when you're talking sinusoidal function, all of these periods are going to be 2 pi. And that's why this is true right here. The period is 2 pi over b, or b is 2 pi over the period. Okay? Now, there's one other thing that can be done, and let me just address this. And let me use a different color. Let me use brown. If I had y equals sine x plus 2, what is that called? What kind of translation is that?
mx plus b?
It's a vertical shift.
Or the 2?
Yeah, the plus 2 is outside the function. That if that was a polynomial, you'd say that was a vertical shift. and D is 2. So is all I have to do to graph that is to take my black curve, move it up 2 units. So instead of starting at 0, it starts there. Does not change shape. And looks like that. Can you see that?
Yeah.
I know there's a lot of different stuff on there and a lot of different colors, but hopefully that shows you the 4 different translations that you can make with the sinusoidal curve. And they're no different than you made with polynomials. It's just they don't act like it's the same. All right, we've got 6 minutes here. Let's do some of these. Let's look at this second one here. I assume you have to do every one?
Yes.
I didn't mean to waste 25 minutes of our hour without doing your problems, but I really feel like that explanation is important to understanding these functions. So, what is A? What is B? What is C? And what is D?
A is 4. B is pi over 6. C is -4.
No, C is actually positive 4 because it's x minus C is the standard.
And D is 0.
Okay. So the only one of these that is problematic is B. If B is pi over 6, what is the period? And that's always the next thing you have to do. Is figure out what the period is. Well, what's the period equal to?
2 pi
over B. So in this case, it's 2 pi over 6. What's that give you? When you divide by a fraction, you flip and multiply.
12.
Yeah. So that's the period. Well, that's pretty easy. That's all they asked for. Give the period. They didn't want us to graph it. So the period is 12. Okay, let's look at the next one. Find the maximum value for this sinusoidal function. What's the maximum value of the cosine of any angle?
I don't know.
Cosine looks like this. And if you want to memorize anything in trig, make sure you memorize your sine and your cosine curve.
Yeah.
That goes from 1 to -1. And it goes out to 2 pi also, just like the sine curve. Notice the one difference. The cosine curve starts at 1. Then it goes down to -1, and then it comes back up to 1. Okay? So tell me what the maximum value of y is going to be. What's the maximum value of cosine of 4x?
So if it starts at 3, or would 3 be the
1.
minimum?
In other words, the maximum value that the cosine of any angle can be is 1. Whether it's 4x or 14x doesn't matter. The cosine of any angle cannot be greater than 1 or less than -1.
Okay.
Okay? So now let's talk a different question. What's the maximum value that -5 times the cosine of any angle can be? Maximum value, not minimum, maximum.
-4?
What if cosine of 4x was pi, such that the cosine of 4x was -1. Now what's minus 5 times minus 1?
-6.
No, minus 5 times -1.
-1.
No,
Or
minus 5 times -1 is a positive 5.
Yeah.
And positive 5 plus 3 is a positive 8. So it's going to be hard for the value of this function to be greater than 8. You can't do it. The greatest value of the part that I have circled is 5, positive 5, and that comes when x is at pi. And then you add 3 to that, you get 8. So the answer to 3 is 8. If you were to put that into your calculator, even though it says no calculator, if you were to put that into your calculator, you would see that your sinusoid function went up to 8 on the top side.
I don't understand how you got that. Like, I understand how the 1 is the max. Is it just automatically the max for any?
Well, let's do this a different way. First of all, let's apply the minus. Let's start with our cosine function. Okay. Goes from 1 to -1. That's y equal cosine x. And now let's look at y equal -5 cosine x. I'm going to draw that in blue. Well, that's going to go from -5 to +5, and it's going to be a reflection. So it's going to look something like this. With me?
Yes.
Okay. Now let's take cosine of 4x. Well, the 4 is a scrunch factor. So in green, I'm going to take my blue curve and scrunch it up so that it fits inside of the origin and the green curve. So something like that. You still with me?
Kind of.
Well, so all I'm doing is applying A, B, and D. In other words, I'm still talking your sinusoid function. And what we're doing is applying each thing. The negative sign means it reflects over the x-axis. The 5 is the amplitude, which means it goes from -5 to 5 instead of -1 to 1.
Okay.
The 4 affects the period. The period, instead of now being 2 pi, is pi over 2. So this is pi over 2 there. Not that that affects much. Notice that that doesn't affect the maximum value at all. But then the 3 moves the green shape of the curve up by 3 units. So if I take my green curve and I move it up by 3 units, it looks something like that. And what's the maximum value? It goes up to 8. Now, I didn't actually have to graph all 3 of these to do that. One thing to really recognize when you're talking about trig is that the sine of x is always greater than -1, greater than or equal, or less than or equal to 1. Very, very important concept in trig. Same thing with the cosine of x. Greater than or equal to -1, always less than or equal to 1. Well, it doesn't really matter if I say cosine of 4x. That's an angle. As long as that's an angle, then that still has to be greater than or equal to -1 and less than or equal to 1. So when there's a B, it doesn't really affect the amplitude. Now, if I put a multiplier in there, say 2, well, now I'm going to go from -2 to +2. Okay, so that -5 was a multiplier, and that affected our maximum value. But the fact is that the cosine of 4x fluctuates between -1 and 1. That's it. And so if I'm looking for the maximum value of this function, I want the cosine of 4x to be -1, because -1 times -5 is +5. In other words, I don't really want the cosine of 4x to be 1, because then I'd be multiplying it by -5, and I'd have -5 plus 3. That would be -2. That's not a maximum value. So you have to be a little clever about these in realizing what you're looking for in order to answer these. But always remember that when you're dealing with trig, sine and cosine fluctuate between -1 and 1. It's one of the most important concepts you can remember. Tangent does not. Tangent actually goes from -infinity to infinity. But sine and cosine, which is what you're dealing with when you're talking the sinusoidal function, the range is -1 to +1.
Okay.
Okay? All right, Marina, I will talk to you next time.
All right, thank you.
You're welcome. Bye-bye.